Hello guys, this is Sir EJ and welcome again for another math tutorial. In today's topic, we will be discussing all about the measures of position for ungrouped data. These are the following objectives that we need to attain for today's topic. Letter A. Illustrate the different measures of positions for ungrouped data. Letter B. Calculate the different measures of position such as quartile, decile, and percentile. And letter C. Interpret and apply the different measures of position in real-life situations. Let's define first what is measures of position. When we say measures of position, these are techniques that divides the data into equal groups. Also, we have different kinds of measures of position. One of them has already been discussed to you, which is under the measures of central tendency, which is the median. The median is one of the measures of position also because it divides the data into two equal parts. Then another type of measures of position are the quartiles, the deciles, and the percentiles, which we will be learning for today's topic. Let's start first with the first measures of position, which is the quartiles. So quartiles are score points which divides the data into four equal parts. We have quartile 1, or also known as the lower quartile, which is equal to 25%, and then quartile 2 is equal to 50%, and quartile 2 is also the median, meaning to say they are the same. The value of the quartile 2 and the median is equal to 50%, and then the quartile 3, also known as the upper quartile, is equal to 75%. And then quartile 4 here is equal to 100%. The next measures of position is the deciles. So if the quartile divides the data into four equal parts, this time the deciles divides the data into 10 equal parts. So we have here decile 1, which is equal to 10%. So from 0 to 10%, this is the decile 1. Decile 2 is equal to 20%. Decile 3 is equal to 30%. Decile 4 is equal to 40%. And decile 5 is equal to 50%. Then decile 6 is equal to 60%, 7 70%, decile 8 is equal to 80%, and decile 9 is equal to 90%. And then for the last one, obviously, decile 10 is equal to 100%. So it divides the distribution into 10 equal parts. And lastly, we have the percentiles. This time, percentiles are the score points which divides a distribution into 100 equal parts. So we have percentile 1 up to percentile 100. So let's say, for example, we are looking for the percentile 5 of the distribution. So percentile 5 is equal to 5%. And also in this example, we have P10, percentile 10 is equal to 10%, percentile 30 is equal to 30%, percentile 50 is equal to 50%, this one is 70%, and this one is 90%, and so on. So that is percentile, are the score points which divides the data or distribution into 100 equal parts. We have three methods of solving measures of position. The first one is by using the general method. Next one is by using interpolation method. And the last one, which we will be discussing for today's video, is the Mendenhall and Sincich method. These are the formulas that we will be using for today's topic. If we are looking for the position of quartiles, we will be using the formula quartile k is equal to k times the quantity n plus 1 all over 4. If we are looking for the position of the decile, we will be using the formula decile k is equal to k times the quantity n plus 1 all over 10. And if we will try to locate the position of the percentile, we will use the formula percentile k is equal to k times the quantity n plus 1 all over 100. To solve for the measures of position for ungrouped data using Mendenhall and Sincich method, we need to follow the following rules. We all know that quartile 2, decile 5, and percentile 50 are all equal with each other because these are scores which is located at the middle. And then for this position, we have decile 1, quartile 1, and percentile 40. We all know that these scores are less than 50%. So decile 1 is equal to 10%, quartile 1 is equal to 25%, percentile 40 is equal to 40%. If we are looking for the measures of position which is less than 50%, and those scores are located at the left side of the data, if the value of the position that we have computed has a decimal in it, we will round up the number. Say for example, the value that we have computed is 6.5. So the value will be equal to 7. If the value is equal to 6.3, that will be equal also to 7. Round up the number. How about if we will try to compute for the measures of the position that is located at the right side of the data, the scores which is greater than 50%. Let's say for example, we will compute decile 60, which is equal to 60%, quartile 3, which is equal to 75%, percentile 90, which is equal to 90%. If that is the case, if it is on the right side and it is greater than 50%, and if the value of the location of the measures of position has a decimal in it, what we need to follow here is to round down that number. Let's say for example, we have compute for the value of decile 6, which is equal to 9.6. So we will round down the number. 9.6 will be equal to 9. Let's say quartile 3 is equal to 11.5. So the value of the quartile 3 will be equal only to 11. Round down the number. So these are the rules that we will follow for the Mendenhall and Sincich method. Left side of the data, less than 50%. If the value is decimal, round up. Right side of the data, greater than 50%, and the value has a decimal, round down the decimal number. Let's have our first example. These are the scores of 12 students of G10 Pythagoras in a 30-item test. The first step we need to do here is to arrange the numbers in ascending order, from the lowest scores up to the highest scores. And then after we have arranged the scores from lowest up to the highest score, the next step we need to do is to solve for the measures of position. Let's say in this example, let's try to solve for the value of quartile 3, decile 4, and percentile 15. Let's compute first for quartile 3. And to solve for the location of quartile 3, we will use the formula Q sub k is equal to k over 4 times the quantity n plus 1. We will substitute the value of k, and that is equal to 3. So this will become Q sub 3 equals the value of k again is equal to 3 all over 4 times the quantity, the value of n, is already given, which is equal to 12, the total number of students who took the exam. So we have 12 plus 1. And then after this, we will be simplifying this equation. 12 plus 1 is equal to 13. 3 times 13 is equal to 39 divided by 4 is equal to 9.75. We will be applying the rules for Mendenhall and Sincich method. Since we are looking for quartile 3, and we all know that quartile 3 is equal to 75%, and 75% is greater than 50%, then this quartile 3 is located at the right side of the distribution. And if that is the case, if it is located at the right side of the distribution, then what we need to do here is to round down the number. So 9.75 will be equal only to 9. So the position of quartile 3 is the ninth number of this course. We will count the ninth number. We have the first number, the second one, the third, fourth, fifth, sixth, seventh, eighth, and the ninth number. So the ninth number is the value of quartile 3, and that is equal to 23. Meaning to say, if we will try to interpret this, 75% of the score is less than or equal to 23. Let's now solve for the value of decile 4. We will be using this formula. Decile sub k is equal to k over 10. If we are looking for decile, this is over 10 times the quantity n plus 1. We have decile 4 is equal to the value of k is equal to 4 over 10 times the value of n again is equal to 12 plus 1. 12 plus 1 is equal to 13. 13 times 4 is equal to 52 divided by 10 is equal to 5.2. Let's apply the rule for the Mendenhall and Sincich method. So decile 4 is at 40%. Less than 50% mean to say it is located at the left side of the distribution. And if it is located at the left side of the distribution, we will round off the number. So 5.2, if we will round up this number, this will become 6. So we are looking for the 6th number of this course. The first one, the second one, the third one, fourth, fifth, and the 6th number. And that is equal to 20. Therefore, decile 4 is equal to 20. Meaning to say, the interpretation of this answer, 40% of the students has a score which is less than or equal to 20. And then let's try to solve for the value of percentile 15. We will be using this formula. P sub k is equal to k over 100 times the quantity n plus 1. And then we have P sub 15, the value of k is equal to 15, equals k again is equal to 15 over 100 times the quantity, the value of n is equal to 12 again, 12 students, plus 1. 12 plus 1 is equal to 13. 15 times 13 divided by 100 is equal to 1.95. Then, perform the rules for the Mendenhall and Sincich method. Since percentile 15 is equal to 15% and 15% is less than 50%, therefore it is located at the left side of the equation. And if it is on the left side of the equation, we will round up the number. So we have 1.95, this will become 2. So we are looking for the second number to get the percentile 15. Count 2 here. This is the first number, and the second number is equal to 9. Therefore, the value of percentile 15 is equal to 9. And if we will interpret this, 15% of the students has a score of less than or equal to 9. Let's have our next example. These are the scores of 14 students of G10 ODLS 8 in a 25-item test. The first step is to arrange the number in ascending order from lowest up to the highest number. We have 2, 7, 7, 8, 8, 12, 13, 19, 19, 20, 20, 21, 23, 25. After we have arranged these numbers, let's try to solve. Say we are looking for the value of quartile 1, decile 9, and percentile 65. So to solve for the value of quartile 1, we will be using the formula quartile k or q sub k is equal to k over 4 times the quantity n plus 1. If we are looking for quartile 1, all we need to do is to substitute the value of k, which is equal to 1, equals the value of k again is equal to 1 over 4 times n is equal to 14 because there are 14 students who took the exam plus 1. We have 14 plus 1 is equal to 15, and then 15 times 1 is 15 divided by 4 will be equal to 3.75. So the position of the quartile is equal to 3.75. Now, using the Mendenhall and Sincich method, the rules have already been discussed earlier. And it says that if we are looking for quartile 1, if it is on the left side of the equation, so obviously quartile 1 is 25% less than 50%, so it is located on the left side. So 50% below. The method that we will be using here, the rules that we will be using here is to round it up. So we will round up the value of quartile 1. So if quartile 1 is equal to 3.75, round up the number. So this will be equal to 4. So meaning to say quartile 1 is located at the fourth number of this course. So we will count these numbers 1, 2, 3, 4. Therefore, quartile 1 is equal to 8. If we will interpret it, quartile 1 is 25%. So meaning to say 25% of the students has a score of less than or equal to 8. Next, let's compute for the value of decile 9. And we will be using the formula of the decile. D sub k is equal to k over 10 times the quantity n plus 1. We will be substituting the value of k, and that is equal to 9. So it will be decile 9 equals the value of k is 9 all over 10 times the quantity, the value of n, the number of students who took the exam, which is equal to 14 plus 1. 14 plus 1 will be equal to 15, and then 15 times 9 divided by 10 will be equal to 13.5. Now, remember the rules. So decile 9 is located at the right side of the distribution, meaning to say decile 9 is equal to 90%, and 90% is greater than 50%. So it is located at the right side of the distribution. And if that is the case, the rule here is to round down the number. So 13.5 will just be equal to 13. And that is the 13th number of this course. So we will count it to get the value of decile 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So the value of decile 9 is equal to 23. Meaning to say 90% of the students has a score which is less than or equal to 23. So that is our interpretation for this answer. Let's now try to compute the value of percentile 65. Using the formula of percentile, P sub k is equal to k over 100 this time, if we are looking for the percentile, times the quantity n plus 1. Substitute the value of k, which is equal to 65. P sub 65 is equal to the value of k again is equal to 65 all over 100 times the quantity. The value of n is 14 because there are 14 students plus 1. And then after that, we have 65 over 100 times 15 is equal to 9.75. And then we will apply the rules in Mendenhall and Sincich method. We all know that 65 percentile 65 is on the 65% of the distribution. And 65% is greater than 50%. Therefore, percentile 65 is located at the right side of the distribution. So the rule here is again to round down the number. 9.75, we will round it down, and this will be equal to 9. We will count the ninth number on this distribution. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and this is equal to 19. If we will interpret this, 65% of the students has a score which is less than or equal to 19. Let's have our last example. These are the scores of 11 students of G10 ODLS3 in a 20-item test. Again, the first step is to arrange the numbers in ascending order from the lowest up to the highest scores. After that, let's try to solve for the value of quartile 1, decile 5, and percentile 75. Quartile sub k is equal to k over 4 times the quantity n plus 1. Let's substitute the value of k in the equation, which is equal to 1. And the value of n, which is equal to the number of students, which is equal to 11. 11 plus 1 will be equal to 12. 1 times 12 is equal to 12 divided by 4, and that is equal to 3. Since the answer for the position of quartile 1 is already in whole number 4, then we are looking for the third number. So we will count 3 numbers starting from 1. So this will be the first number, the second number, and the third number. Therefore, the value of q sub 1 is equal to 9. If we will try to interpret this, 25% of the students has a score of less than or equal to 9. And then, let's try to solve for the value of decile 5 using this formula. And we will substitute it again. The value of k is equal to 5. The value of n is equal to 11. 11 plus 1 is equal to 12. 12 times 5 is equal to 60. 60 divided by 10 is equal to 6. And then after we have compute for the position of decile 5, since this is a whole number, we will just look for the 6th number of this given set of numbers. This one will be the first number, second, third, fourth, fifth, and the 6th number. Meaning to say the value of decile 5 is equal to 13. Therefore, 50% of the students has a score of less than or equal to 13. And then let's try to compute for the value of P75 this time using this formula. Substitute the value of k, which is equal to 75, and the value of n again is equal to 11. And then 11 plus 1 is equal to 12. Lowest term of 75 over 100 is equal to 3/4. 3 times 12 is equal to 36 divided by 4 is equal to 9. This is already in whole number 4, so we are looking for the 9th number to get the value of P75. So we have first number, second, third, fourth, fifth, sixth, seventh, eighth, and the 9th number, which is equal to 17. P75 will be equal to 17. Therefore, 75% of the students has a score of less than or equal to 17.